Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and from this lecture onward we will be moving into another very important aspect of sequence stratigraphy, another very fundamental aspect of sequence stratigraphy, where we will be discussing about the different types of system tracts. So, system tracts are the fundamental units of a sequence. Sequences are made of multiple system tracts. So, starting from this class onward in next several classes, we will be discussing about the different types of system tracts. So, this class is a sort of overview on these different types of system tracts that we will be discussing in next few classes. As we already know that a system tract is a linkage of contemporaneous depositional systems forming subdivision of a sequence as per the definition of system tract. So, a system tract commonly includes all strata which are accumulated across the basin during a particular stage of shoreline shift. This definition we have discussed earlier also during our discussion on the basic elements of sequence stratigraphy. There we discussed about this basic definition of system tract. So, in case of system tract, we commonly interpret them based on the overall stratal stacking pattern. We have seen earlier that based on the shoreline trajectory, based on the shoreline shift, there can be different types of stratal stacking pattern which can be identifying for a particular system tract. So, we can identify that stratal stacking pattern, we can relate that stratal stacking pattern with a particular system tract. We can identify the system tract with respect to its position within the sequence and what are the bounding surfaces. So, this position within the sequence or the type of bounding surfaces, they are commonly determined with respect to the timing of the events occurring with respect to the fundamental base level curve, the fundamental change in the base level condition with respect to time. So, again I will refer back to that very fundamental base level curve that we have discussed earlier also, and we have referred back to that again and again. So, based on that basic fundamental base level curve, we can identify different events, and those events help us to identify the system tracts. So, along a shoreline, if I look at the base level curve very quickly, I will just like to go through that part just to recall. So, the base level curve moves like this. So, within this base level curve, we can find out several boundaries. For example, one boundary over here. The second boundary is somewhere here, which is at the peak of the fall. This is the peak of the rise. Then we get another boundary somewhere here, which marks the start of transgression, end of regression, and another boundary somewhere here, which can be the end of transgression, start of regression, and then followed by this, again it starts with the fall. So, this portion is the forced regression, as we already know. This portion is the normal regression, this portion is the transgression, and this portion is again a normal regression. As we already know the boundaries, the name of the boundaries. So, this surface is commonly identified as an unconformity surface, or it can be identified as a BSFR surface. This surface is commonly identified as a correlative conformity surface, or in fluvial section it can be an unconformity surface. The contact between normal regression and transgression, it is identified as the maximum regressive surface. The transition from transgression to the next normal regression, it is identified as the maximum flattening surface, and again we are coming back to this surface 1. So, these packages, they are formed in between these phases of events. They are indicating a particular phase of shoreline trajectory. So, all the depositional systems which are forming during these phases of shoreline trajectory are identified as the system tracts. So, already we know that package of sediment, that assemble of depositional systems which will be associated with forced regression, these are called as falling stage system tract. falling stage systems tract. Similarly, those depositional systems which are associated with this phase of normal regression, they are commonly called as low stand systems tract, LST. Similarly, those depositional systems which are associated with transgression bounded by MRS and MFS, they are identified as TST or transgressive systems tract. And similarly, when we look at the MFS to the next unconformity or BSFR, the next normal regressive package, this is called as the high stand systems tract. So, commonly we get these four, the FSST, we get LST, we get TST and we get HST. And in some cases this FSST, LST and HST, if I start from here with an HST at the top, then this HST, FSST and LST together will form an RST, regressive systems tract. So, in those cases we can identify only two, a TST and RST. So, broadly in marginal marine systems we can identify these 5 systems tracts: high stand systems tract, falling stage systems tract, low stand systems tract, transgressive systems tracts and in some cases a regressive systems tract. So, in successive classes we will discuss about these different types of systems tracts in detail in terms of what are the distribution of different depositional systems, what are the processes, what are the events that occur during this particular systems tract, individual systems tracts in marginal marine systems. So, commonly a systems tract includes the sum of laterally correlative depositional systems. So, when I am talking about a TST, that means it is a transgressive systems tract, and then we are considering all the depositional systems which are occurring across the basin and how they are depositing sediments in terms of facies architecture during that particular phase of transgression. So, a sequence, it should always include 2 or more systems tracts depending on the model of choice. As we have seen, there can be different orders as well, and we can define them in terms of different hierarchy. Now, apart from these 5 major systems tracts that we very commonly can identify in the marginal marine system, basically in the marine system actually, including the marginal marine system and those fluvial systems which are associated with the marginal marine system, commonly we call them as the downstream fluvial system, downstream settings. So, we can apply these 5 systems tracts over these entire depositional conditions. But when we look into the more continental side, where the effect of base level change has no direct effect on the depositional conditions, in such areas the depositional systems are controlled by some other factors, not by the base level change, and in those conditions particularly we call them as upstream controlled fluvial settings. In those areas we can identify 2 more systems tracts. One is called as LAST, that is low accommodation systems tract, and second one is called as HAST, high accommodation systems tract. So, these 2 systems tracts can also be identified particularly in the upstream controlled fluvial settings. We will discuss about these systems tracts separately when we will discuss about the fluvial sequence stratigraphy. So, commonly each systems tract is defined by a particular type of stratal stacking pattern. When I am talking about a TST, it will be overall retrogradational pattern, overall it will be backstepping pattern, and overall it will be finding upward package. So, this kind of stratal stacking pattern, the characteristic of stratal stacking pattern closely associated with a type of shoreline shift. So, accordingly we can get a particular type of stratal stacking pattern during forced regression, during normal regression or transgression, and commonly this kind of stratal stacking pattern is associated with a stratal termination. So, when we combine these two, the stratal stacking pattern and the stratal termination associated with a particular phase of shoreline shift, very easily we can identify that event and we can identify the systems tract. So, individual systems tracts, they represents a specific sedimentary response to the interaction between sediment flux, the overall physiography and the environmental energy. And in response to all these, what is the final net accommodation available, where how much accumulation of sediments can take place, what will be the nature of accumulation of sediments. So, again I will refer back to that concept of accommodation versus base level, the accommodation equation. So, there we have already discussed about what are the different factors that control accommodation. So, to identify a system strat, we have to understand that concept of accommodation. We have to understand that in a particular depositional setting, how the accommodation condition is changing with respect to changing base level condition, because that will control the accumulation pattern of the sediments, accumulation pattern of the depositional systems. So, very broadly we can go through overview about the what will be the regional architecture in terms of the distribution of different depositional systems during different system strats, or rather during different phases of shoreline shift. If I identify them in terms of these 4 major system strats, LST, TST, HST and FSST, what will be the overall regional distribution of different depositional systems? Definitely we will discuss about this in more detail, but in this class, as this is an introduction to the system strat, through a very simple diagram I will try to give you an overview about those conditions. So, let us think of a marginal marine setting like this, which is continuing into the deep marine part. So, this is the condition which is, say for example, we are thinking of a base level curve which looks like this. So, in this base level curve, let us start with an HST condition. So, first we are looking at HST condition. So, this is the high stand system strat. So, during this time, what kind of depositional system we expect, without going into the detailed explanation that why this is happening and how this is happening, because that we will discuss separately on a separate class on HST. Just we should look into what are the depositional systems that will occur during an HST. So, for HST we are looking at this part of the curve. During this part, what is happening, the overall sea level, say for example at the start of the HST, sea level was here and this is rising up and it is reaching somewhere here, which is level 2. So, definitely this surface marks the end of the transgression which was preceding the HST phase. So, this surface is the maximum flooding surface occurring in that particular basin. So, during this HST phase, what we expect, most of the deposition occurring in the fluvial part, where the fluvial aggradation will take place, fluvial system will aggrade and they will be interacting with marine system. So, definitely they will be part of the delta plane, and that delta plane along with aggradation it will prograde, and that progradation will result in this kind of prograding lobes. So, what we expect over here, formation of this kind of prograding lobes. So, this will continue up to certain extent, and then as the water level is higher as it is over here in this part, the supply of these coarser clastic, supply of these terrigenous sediments will be restricted more towards the shore area, and as a result in this deeper part starting from outer shore, maybe outer shore face to enter shelf, it will be part of a thin deposit of mud, hemipelagic to pelagic mud, which we commonly call as the condensed sections. So, during this entire HST, a major part of the basin is associated with deposition of mud, pelagic to hemipelagic mud across this entire area without any major changeover, any major process going on, and the major processes are confined over here where it is associated with progradation and aggradation, that is leading to progradation and aggradation of delta lobe in the form of aggradation of the delta plane and progradation of the delta front as the river system is prograding up there. So, definitely the coarser sediments will be confined in this part only. So, this particular surface for this particular base level condition, what is the final surface we are getting over here? this is the final surface that is available to us at the end of the HST phase. This is the final surface. Now we can move on to the next phase, that is the falling stage system struct. So now the base level is falling. So maybe it is falling down to this level. From level 2, it is coming down to level 3. So at level 3, so the water level is somewhere here, or the base level is somewhere here. So definitely in this part, there will be successive erosions, and that erosion will gradually come down and it will reach over here through successive prograding lobes. And at the end, what we will get? A final erosional surface in the form of an unconformity over here. And in response to the sediments which are derived by this erosion process, they will be coming over here and they will get deposited in this part like this. So we get a delta formed over here near to the self edge or onto the shore area, where a delta will be prograding without much aggradation. And also in response to this delta, what we can expect in the deeper part of the basin, we can get very frequent development of very frequent emergence of high density turbidity currents, and maybe during the late phase of the forced regression, we can expect some low density turbidity currents. So these are high density turbidites and these are low density turbidites, which will also form during this phase. Apart from these areas, we will not get much deposition except this delta forming over here. So what is the surface we are getting at the end of falling stage system struct? This is the surface, the unconformity, which is continuing over here up to this point as unconformity surface, and then we will get offlapping lobes, and those offlapping lobes will be ending up with a correlative conformity surface. This is the correlative conformity surface, and then here also we will get the correlative conformity surface. What is the underlying surface? So over here we will get a BSFR surface, basal surface of forced regression. Over here we can get a BSFR surface, provided it is not reworked by waves. Subsequently, it is not reworked by waves. In those cases, we will get a RSME surface, and in rest of the part, we will get unconformity. So this is the scenario during the falling stage system struct. So what are the depositions? Deposition is mostly confined in the outer shore to self environment and in the deeper marine part in the form of low density to high density sediment gravity flows, mostly turbidites, as well as formation of a delta near to the self edge or onto the shore environment, depending on how much is the forced regression going on over there. So when we are talking about this particular phase within this curve, we were looking at this part of the curve, this part of the curve. So this entire thing that I have drawn in red color, this will happen during this phase of the curve when the base level is falling. Now we are looking into this part of the curve, this yellow part, where the base level has started rising, and as we know, this is a normal regressive condition. So from this stage 3, the base level is rising up to, say for example, level 4. So for this level 4, the water level or base level is reaching somewhere here. For this much of rise of the base level, what will happen now? There will be accumulation of sediments, and that accumulation will be mostly confined in this particular zone, as the river system will now accumulate. It will aggrade as well as prograde, as well as the rear part of the fluvial system that will start onlapping as it will gradually aggrade up. So what we get? We get, say for example, if it is starting from here in this level, so the next fluvial system will be here, as well as it will produce a delta system over here. So we will get the clinoforms prograding and it is aggrading. The next fluvial system will be prograding as well as aggrading. So the prograding clinoforms will be like this and it will go on like this. So the shoreline, which was lying somewhere here, it is moving in this direction. So it is a progradation, and we are getting a delta forming over here, as well as the fluvial system is onlapping, fluvial system is going back gradually. it is aggregating and going back. And since we are now having a relatively higher water depth, so the supply of coarser clastics will be less. So, what we expect in this part, we can get lobes of low density turbidites. They will form in this kind of conditions. So, at this phase, during this particular phase of low stand system extract, what you can expect? We get formation of fluvial and deltaic condition. Fluvial and deltaic condition which will start developing near to the self edge, and from there it will try to retreat back as well as prograde. And along with that, in the deeper part, we get deposition of these low density turbidites, which will be the representation of the low stand system extract. So, this part is actually representing the low stand system extract, which is a normal regression formed during this phase, this rising phase of the base level. So, low stand system extract will produce a normal regressive package, a progradational package where the aggradation will be less, but only in the fluvial part we can expect aggradation with some onlap of the fluvial system. And now coming into the fourth stage, where from this level 4 the base level is further rising up and it is reaching up to level 5. So, now we are looking into this part of the curve where the base level is rising at much higher rate with respect to the rate of sedimentation. So, for this particular level, water level is reaching somewhere here. So, now the basin is covered up by water, it is under entire water cover, definitely in phases. So, when this is happening, this shore system, this will try to onlap over here, and when it will be onlapping into the earlier incised valley system. So, definitely here we will get formation of estuaries. In this portion, the fluvial systems will be completely flooded up. So, we will get fluvial onlap in these areas. As we have seen in case of LST, the fluvial system will try to aggregate and they will start onlapping. Also, we will get this kind of retrogradation in the shore area. So, these two together will produce the coastal onlap, and we can expect in this part an onlapping package. So, this is called as the marine onlap. Commonly, we do not get any deposition occurring over here in this zone, and in some cases we can get just a deposition of a condensed section in this part of the basin, because this area remains starved in terms of sediment supply, in terms of supply of sediments from the landward side. So, we can get some turbidite deposits which are gradually retrograding, as well as we can get some low density turbidites over here in this part. So, these deposits are also called as healing phase deposits, which will form during this TST. So, this blue color portion that I am drawing over here, this represents the TST part. So, during this TST, what we are getting now? We are getting a deposition occurring in the fluvial part in the form of fluvial onlap. We are getting a deposition occurring in this marginal marine part in the form of estuary or coastal onlap. We are getting another deposit in the depressional part where we are getting a marine onlap. All these are occurring along a surface which is the last phase of deposition at the end of the low stand system extract. So, that surface, for example, this particular surface, this surface is the maximum regressive surface, and definitely the surface that is ending up at the end of the TST, that will be the maximum flooding surface. So, we can identify the maximum regressive surface across the entire basin, and we can identify the maximum flooding surface in certain zones, in certain areas, for example, in the fluvial onlap part, in the coastal onlap part, in the marine onlap part. So, in subsequent classes, we will discuss about these distribution patterns in more detail, and we will try to understand what are the change in processes, what are the change in conditions in these individual system extracts, whether it is an HST, whether it is an FSST, LST or TST. what actually happens across the entire basin in a marginal marine setting in ideal systems. We will try to understand what will be the distribution of different depositional systems during each of these system strats. Commonly, we explain or represent this transition of different depositional systems during the system strat or across the system strats using a Wheeler diagram. Wheeler diagram is a very popular diagram in stratigraphy, where we try to represent the depositional pattern of different strata through time, and that can be represented in terms of TR cycles. Say for example, over here in this particular diagram, as you can see, this is the time axis. So, these horizontal lines are the time planes. So, if you take any time plane, for example, if I take this particular time plane, so along this time plane, this is a part of HST. So, we know during HST we get normal regression. So, during normal regression, what happens? The fluvial system will prograde, the beach system will prograde, shore face system will prograde, each of them will be prograding, and finally we are reaching into the self system, where also we are getting progradational pattern. And the self system is a condensed section, as I have told you in the previous diagram. So, during this entire self area we get similar type of phases, similar type of depositional condition. If I look at somewhere here in this part, which is a part of the TST, so as we know, during TST it is a transgression, during TST it is a retrogradation. So, during TST part, what we expect along individual time plane, the depositional systems will be migrating towards the land. So, at time, say for example time T1, time T2, there will be a shift towards the land of individual depositional systems. So, this is a kind of representation of the distribution of different depositional systems along time. When you merge these time planes one after another, you get this diagram. So, this is one of the very popular way of representation, particularly understanding of the distribution of different depositional system within a basin across time. Now, if I want to look into the grain size distribution trend along the vertical profiles of various system strats, definitely we will discuss about this in more detail, but in a very summarized way I can try to give you an idea. So, when we look at the, say for example in the HST part, so within the HST we can find out at least different depositional systems or different depositional conditions. For example, we can get a fluvial system, we can get a coastal system, we can get a shallow marine area or shore area, and we can get a deep marine area. Maybe shore can be replaced with self as well, self system as well. So, during HST part, in the fluvial part, fluvial system, what kind of grain size distribution we can expect? There we are getting aggradation, and when it is aggradation, so more floodplain deposits will be dominant. So, overall if I look at individual units, individual channel units, there will be a finding upward trend. But as we move forward with HST, gradually the more channel amalgamations will take place, and that more channel amalgamations will lead to an overall coarsening upward trend. So, in this case commonly we can expect an overall coarsening upward trend, but if you look at individual portions, individual channel amalgamations, then you will get finding upward trends. When you look into the coastal part, there we can get formation of a delta, where the delta mouth bar will be prograding onto the delta front will be prograding into the pro-delta. So, always we can expect a coarsening upward trend over here. But again within this part also, if you look at individual packages, there can be localized finding upward packages. In the self area during HST, we do not get any change, because there we get a condensed section, there we do not get any change in terms of variation with respect to grain size distribution, because it is an overall very low energy condition. And further in the deep marine part, there also we do not get any changeover. If I look at the FSST package in terms of grain size changeover, in the fluvial part I will not get any kind of changeover, because it is a part of erosion now. There is no deposition going on, so I will not get any kind of changeover in terms of grain size distribution in the vertical profile. In the coastal area, we cannot get anything if there is an erosion going on in the coastal area. If the amount of forced regression is high, then the coastal area will also be affected by this erosion or bypass, and we will not get any deposition over there, and so we will not be able to distinguish any grain size distribution trend. If in the coastal area we get FSST, so definitely within the FSST part we can get a coarsening upward trend. When I come into the shore face and self area, this part is the dominant area where we get deposition during the forced regressive phase during the FSST, and there definitely we will get a coarsening upward trend for each deltaic lobe, because as the delta will be progressing forward, we get the delta mouth bar will be progressing on the delta front will be progressing on the pro delta, and it will go on like this. So overall it will be a coarsening upward package, but if I look into a delta plane area, if it is progressing into this area, then within the delta plane individual channel systems again can show localized fining upward successions. And in the deep marine part, there we cannot get any definite trend, because there we are getting a completely different depositional system where high density turbidites and low density turbidites will be deposited in different areas. So within high density turbidites or low density turbidites, depending on the successive accumulation of the turbidites of different densities, we can get different trends. So somewhere locally we can get fining upward, somewhere we can get coarsening upward trend. Now looking into the LST part, low stand systems tract. So in the fluvial part we get this fluvial aggradation and fluvial onlap. So definitely in this part the fluvial amalgamation of the channels, that will be very high, and commonly they are of relatively higher energy condition. So commonly in this kind of condition we can expect a coarsening upward trend within the LST part, where the grain size is gradually increasing towards the up. But again, if you look at individual channels, then within the channel there will be a fining upward trend as individual channels will be overlapped by or covered by the flat plain deposit. In the coastal area, it will be definitely a coarsening upward trend as there will be a progressing delta system. In the shore face self area, again we will get a coarsening upward trend, as well as in the deep marine part we do not expect any particular trend to develop, as in this area we get low density turbidites. So when these low density turbidites will accumulate, depending on what type of grains are actually coming in a particular turbidity surge, we can get different type of packages, different type of distribution of grains within the vertical profile. And finally coming into the TST part, we will get a overall fining upward trend even within the fluvial part, because here the fluvial systems are aggrading as well as they are onlapping. So when this aggradation is going on, so these fluvial packages, they will be associated with less channels, less amalgamated channels, and more abundance of the flat plain deposits. So more abundance of flat plain deposits will result in overall fining upward trend. Similarly, in the coastal areas, we expect overall fining upward trend as there will be a retrogradation of all the depositional systems, and more deeper faces will come over the shallower faces. In the shore or self environment, again we will get a fining upward trend as the self deposits will come over the shore environment, deeper self will come over the shallower self. So overall we will get a fining upward trend. But if it is the entirely within the self area, there we cannot get any trend because it will be same kind of sediments. And in the deeper part of the basin, there we can expect either a coarsening upward or a fining upward trend, depending on in which part this is occurring. If we look at the marine onlap part, where successive density flow deposits are getting accumulated, there we can expect a coarsening upward trend. But if I look at the distal part, there may be a fining upward trend may be produced as the supply of the coarser clastics are gradually decreasing, and that may lead to less supply of sediments into the successive low density turbidites. So the overall depositional pattern will be a fining upward. So this is just an overview of what kind of sediment package or grain size distribution we can expect in different system tracts. However, this can vary enormously along these different sub environments in different system tracts. So that variation, what kind of variation we can expect, what kind of variation may occur, that we will discuss in more detail in our successive classes when we will discuss about the individual systems tracts. So, each of these systems tracts and the resultant package of sediments, they are associated with different economic opportunities in terms of the mineralization, the occurrence of different resources, for example, the occurrence of petroleum, for example, the occurrence of coal. So, often we try to identify or relate these systems tract with respect to petroleum plays, with respect to pit forming mires, what are the different conditions, favorable conditions for these economic potentialities, and hence based on these models we try to develop the possible or the best fit exploration strategies. So, the exploration strategies will change depending on what kind of package we are looking at. If it is an FSST, we will have one kind of exploration strategy. If it is a TST, we will have another type of exploration strategy, because the accumulation of these resources, coal or petroleum, they will vary, their positions will vary depending on in which kind of package they are occurring. So, this aspect also we will discuss in detail with respect to individual systems tract, with respect to whether that is potential for coal accumulation, whether that is potential for petroleum accumulation. So, that also we will discuss. So, with this I will conclude this particular class. So, this is just an overview of different types of systems tracts. These are some of the references. We will follow these references also in next classes as well. So, you can go through these references for further detailed study, and in the next classes we will discuss about the individual systems tracts, and we will discuss about their detailed characteristics and how to identify them in rock record. So, thank you everyone.